Hello everyone. Today we are going to see a small example of how to use a display of 16 by 2 characters. As you can see here on the image, we have 2 lines. Each line has 16 characters where we can place numbers of letters according to our project requirements. So we will move quickly into the firmware in order to use this display. So as usual, we'll be using the CCS C Compiler, and we'll create a new project for working with the 16F873A microcontroller. So before to start writing any code, we need to include a library inside the folder of our project. And now I have the library here in my desktop, so I'm going just to drag this file inside the folder of my project. As you can see here, it's Flex LCD. I will copy this name and I will include it into my project by writing just include and then the name of the file.c, and that's it. We can verify if it's correctly linked by compiling. And if we don't have any errors, it means that everything is okay. So we'll start by doing the typical hello world program. So first of all, we'll need to put here, before writing anything, a command for initializing the display, and this is called LCD init, and that's it. This is a function that is inside this library, Flex LCD, that is going to send some small commands to the display in order to work in the conditions that are suitable for our project. So I don't want to get inside the meaning or what exactly is doing this function, because it's not relevant at this moment. So we'll skip that, and maybe in another video we can clarify this, or maybe you can ask in the comments. The first step that we have to perform here is to tell to the display where we want to print our message. So for doing that, we will write just this basic command, which is LCD go to XY, which is a command that is actually locating a cursor in a given position. In this case, the X are the columns and Y are the lines or the rows. Now we have to print the message in that position. We have to remember that message has to be shorter than 16 characters, or shorter than 16 characters minus the position of X. So if we locate, for example, a message in the 3rd position, we have just a space for 13 characters. In order to print the message, we go for something really simple, which is print F, and inside here we will put LCD, put C, comma, and then in quotes we have to put the message, and in this case will be hello world. And that's it. That's everything we need. We can go here and compile the project. Now we have here a small mistake. It's just go to, and now we're going to create the schematic in order to perform the simulation of this firmware. This display, it's sometimes a little bit difficult to find, but this is the code that you have to write in order to find it easily. It's LM016L, and that's it. So now we are going to start locating the different components. And something that I didn't clarify so far is where we are going to how we are going to connect all the pins of the display. And I didn't do it because this is already done here inside this library file. So we will open this and we will see here that is already defined. For example, the LCD has 4 pins for data in this mode, in which we will find in this library. So we'll go from DV4, DV5, DV6, and DV7, and each one of them is connected to, for example, pin B4, B5, B6, B7. That is something that you can change as you wish. I will keep it like this because for me it's okay. An important thing here is that we have this pin, which is RW, and RW it's just a pin that will allow us to write information into the display, and also will allow, depending on the pin value, will allow us to read information from the display and send it to the microcontroller. In this case, the only thing that we are going to do is just to write information into the display. So we'll put this to ground, as you can see here, directly, because 0 in this pin means that we are going just to write information. So by doing this, we save a pin on our microcontroller. So here it's a display already working. We can play a little bit with the position of the cursor, so we can locate the message in different parts of the display. But now I would like to go a little bit more inside, a little bit more deep. So for example, let's say we want to read some values from the ADC, and we want to put the readings on this display. Let's say, for instance, we want to make some small voltmeter, so we can read, for example, the value of the analog port here in the pin number 2, and then show the value of this voltage in the message. But this is a little bit more complicated because we have to introduce some functions for reading the values of the ADC module. The easiest way is just to go here to help and write ADC. There are many examples here that you can just copy directly, and that's what I'm going to do exactly. I'm just going to copy this, and this, and I'm going to adapt this for our project. Okay guys, here we have the code finished. You can stop the video and take a look in detail of all the codes, all the functions that we're using. So I'm going to roughly explain them. Okay, first of all, here we have a float variable that I create. It's called reading ADC. It's this type of variable because we have to locate now the readings from the ADC. And in this case, the readings of the ADC, they are configured to be in between 0 and 65,535. And this is something that we can change. Okay, we can, for example, have readings from the ADC that can vary from 0 to 1024 by going here in this file mine.h. We open the file, and then we will see that there is a definition here, which is define ADC 16. So the meaning of this is that the readings from the ADC, they will have a sensibility of 16 bits. By using 16 bits, we can go from values that are between 0 and 65,535. Let's say, for instance, we put 8 here, so we will have values that are going to vary from 0 to 1024. And this is going to have more sense in the following commands, so you will see why I left it just like this. So here inside our void mine, we have the initialization for the display, as before. We have a setup ADC, which is configuring some parameters for the readings of the ADC, as the same as here, setup a ADC port, which is configuring which of the pins are going to work as analogs. Here, for example, we have from 0 to 5. We can configure just to have, for example, the first pin as an analog pin. So just for the sake of simplicity, I left them all analog, since I'm not using any pin on the A port. And then I introduce a small delay, because this is a requirement for the ADC module. We need a small delay before the first conversion. So here inside of our infinite loop, we have a function which is called set ADC channel, and we use this one because the ADC module, what it's doing is just sampling every single pin, and now we have to tell which one of the pins we are interested on. So let's say we are interested just on this pin, so we go and then we select this channel by putting 0. We can, for example, select another channel by just changing this number. When we select this number, we can start the readings. We can start reading the values. So here I use a variable that I have defined before, and I allocate the value of the readings inside this value. Once I have done this, I can continue with the procedure that I have done before with the hello world example, but the only difference here is that I'm using these letters here. The percentage is indicating that we want to put a value of a variable inside. The 2.2 particularly is just a way in which I can give a format of this value, because this reading ADC can take, for example, a lot of numbers before the comma and after the comma. So by doing here this, by writing this, I'm just telling that I want to have 2 values before the comma, and then I will round all the decimals into 2 numbers that are going to be after the comma. Here the F, it's just to indicate the kind of variable that we want to write inside, and since this is a float, I have to put an F here. There is a factor of multiplication here, and this is coming from the fact that every increase on the reading that I get from the ADC corresponds to a division of 5 over the sensibility of our reading, and in this case the sensibility of our reading is 65,535. So if you make this division, you will get this coefficient. So everything that you see here is just to have the printed value in terms of voltages, because otherwise we will have them in terms of just this value that you see is going to vary from 0 to 65,535. So it's okay, but it's not really showing the information that we are really interested on. So okay, we can compile this and go to Proteus. So now we have 8%, which is 0.40. But before going ahead, let's put here a voltimeter. So let's see if the readings they match. I think they will. Now you will never know if you don't try it. We put the ground here. Okay, let's see. We have 0.40 and 0.40 here. We can increase this a little bit, and then increase again, and okay, so you see there is a small difference, and it's just because I didn't take all the decimals from the division of 5 over 65,535, and this is just a small error that I can easily tolerate, so for me it's okay. But with this we conclude this small example. I think it will be really helpful for the people which is starting with this. Also, not only with the display, and it will be also useful for the readings by using the ADC components inside the microcontroller. So of course, if you have any question, just leave your message and I will try to answer as soon as possible.